Hello. So in this session, we'll be looking at factorizing expressions. So last time we looked at expanding brackets. So stuff like x plus 4, x minus 1. Obviously that expands to x squared minus x and 4, that would be plus 3x um, minus 4. So then what we're going to look at in this session is basically to do the opposite, right? We can factorize, we can put stuff back into brackets. And so what we mean by factorizing is we express something into factors, okay? So just either with numbers, for example, uh, 4, 4, um, we can factorize it because we know its factors are 4, 2, and 1. So we could say it's 4 times 1. That's one factorization of 4. Or we could say 2 times 2, right? So that's the other factorization of 4. Okay, so notice a factorization is a product of factors, okay? So we're tying two numbers together, right? So that's essentially all we mean by factorizing. And actually, it turns out we can do it with algebra as well. And you can see here, if we go backwards, we have these two brackets. These are the factors of x squared of 3x minus 4. X plus 4 is a factor, and x minus 1 is a factor. And notice there's a secret, if I rewrite this a little bit, because they're together, there's a secret times sign, right? So it means we're multiplying together. So these two are factors, okay? And so that is our aim, essentially, is to now work backwards to what we did last time. Instead of expanding and stuff like that, we're going to factorize. Um, and so we're going to look at some expressions to factorize. Okay, cool. So let's look at this example first. So we are required to factorize these expressions completely. Okay. So let's do a pi a 3x plus 9. So when we factorize, we seek to find out factors, right? Things or numbers we can pull out that will go into all the terms that we have. So it's a common factor, okay? So in this case, it's a fairly simple case, but we can see that 3x and 9, well, 3 goes into both terms, right? 3, and then if we factor out the 3, well, x times 3 would be 3x, so it'd just be x. And then 9, it would be, how do you get from 9 using 3? 3 times 3 is 9. So that's our factorization, right? And it's simplified because x plus 3, we cannot pull, there's no more common factors we can pull out, okay? Apart from 1. But any actual number, right? We can't simplify it anymore. We can't pull out any other factors. So this is factorized fully. So the whole idea then, as you think, if we look sort to find out a common factor of all the terms, which was 3 in this case, because 3 goes into 3x because of 3 times 1 is 3, and then 9 goes into 3 as well because 3 times 3 is 9. Okay, cool. And then part B, we have x squared minus 5x. And again, what factor is common? What number or term goes into both individual terms, right? The x squared and the minus 5x. Well, it's x, isn't it? And remember, you can include terms to pull out as well instead of just numbers. You can use algebra as well. So x goes into both of them because then x times x will give us x squared. And then for the second term, x times minus 5 will give us minus 5x, okay? And if you are unsure with factorizing, remember you can go back and reverse and expand the bracket. So, for example, part A again, 3 lots of x plus 3. If we expanded it, as it's in the last section, you do the number out in the front times by every term inside the bracket. So 3 times x would be 3x, and 3 times 3 would be plus 9. And that's exactly the original expression, okay? So it's really it's a good tool to check your answer, right? by recognizing their reverse, by doing the reverse, right? Anyway, so part C, then we now have 8x squared and 20x. Well, immediately I notice x is in both terms, so I can pull an x out. But also, let's look at the actual numbers as well, the coefficients. Well, 8 and 20, I know 2 is a common factor in both of them as well. And it's the highest common factor. Because then 2 times 4 would be 8, and then 2 times 10 would be 5. But I think we can do better than 2, right? Um, we can say 4, right? Because 4 also goes into it. So actually, 4 is the highest common factor. And so then 4x, how are we going to get 8x squared from 4x? Well, we're going to times by 2x, right? 4 times 2 is 8, and then x times x is x squared, okay? And then for the second term, the 20x, well, we already have an x, so then just to get 20, we're going to times by 5, aren't we? Because then 4 times 5 is 20, so we get 20x. Cool. If we were a bit stuck, perhaps like I said, maybe if you said 2x instead, if you couldn't recognize what factor, what highest number goes into both terms. Say if I said 2x, right? Then 2x, how did it get to 8x squared? Well, we said it'd be 4x, wasn't it? Because then 2 times 4 would be 8. And then for 20, we would have 10x, right? 10. Because then 10 times 2x is 20x. But actually, then that's not fully simplified because then you should spot this also has a common factor of 2 in both terms, right? So we can factorize out 2x, and then I can factor out a 2, right? Because then 4 and 10, the 2 goes into both of them. And then if I factor 2 out in the bracket, you'd be left with 2x plus 5, right? And then if I do 2x times 2, that'd be 4x, right? And then 2x plus 5. And that exactly matches our result here. Okay, cool. So yeah, so if you were ever a bit stuck exactly what factor to spot, to try and spot a factor, and then if there's more factors there, then you'd be able to factorize and simplify further. Okay. But yeah, cool. Part D, we have 9x squared y and 15xy squared. Okay, well, I noticed xy is firstly a common factor in both of them. We have x squared y, that'd be x lots of xy, right? And xy squared would be xy times y. Okay, but that's the only the only factor we can pull out with the algebra, right? Um, so it'd be xy, but also then let's have a look at the numbers. Well, 9 and 15. Well, because spot 3 goes into both. 3 is the highest factor, right? So 3 goes into both terms as well. So 3xy, then to get to 9x squared y, well, 3 and then another 3 gets us 9, and then an x squared, well, I need to times by an x, don't I? So an x times x is x squared. So then if I did this expansion, 3 times 3 is 9x squared, and then a y. Cool. Okay, and then what about the second term? Well, 15 again, get from 3 to 15, you're going to firstly have a 5. And then I have an x already, I have a y, but I need a y, another y to get to y squared. So 5y, and that should be a factorization. Cool, and we can't simplify it any further. There's no more terms that go into, the things in the brackets. Okay, cool. And hopefully you can spot what we're kind of doing now. Hopefully, the strategy, right? Because with these sort of algebraic questions, you spot the physical numbers, the coefficients first, and then the algebraic terms, so how many x's or how many y's are in each term, and then use that to help us factor everything out. Okay, so let's have a look at part A. Then we have 3x squared minus 9xy. Again, I noticed 3 is a common factor in both, so I can take a 3 out, but also x as well, right? So I have a 3x. And then, wow, what about the first part then? I need another x, don't I? So then x times x, x squared, we get 3x squared. Cool. And then what about minus 9xy? Well, I already have an x, so to get from 3 to minus 9, I'm going to need minus 3, right? But then I need a y as well to get to minus 9xy. And there we are. That's our factorization. Cool. Um, but also, you will be expected to factorize quadratic expressions. So let's have a reminder from that. Again, all of this should be from GCSE, but we will look at harder questions towards the end that are more exam related. But it's good to practice. So let's look at part A, x squared minus 5x minus 6. Well, with factorising quadratic, you should remember probably the best way to do it, at least when you have a coefficient of 1 when it's just x squared. For example, in part C, we have 6x squared. But if you just have 1x squared or x squared, what you can simply do is, well, just consider the factors of minus 6, right? So it'll ultimately want two numbers that times to give minus 6 and add to give minus 5, right? So I'm reading off the coefficient, right? Times to give the number at the end, so minus 6, and as to added to give minus 5, the coefficient on the x. Okay, so hopefully that should refresh your memory. And so the easiest way to consider two numbers that times multiply to give minus 6 and add to minus 5 is to consider the factors of minus 6 or 6, right? So then if we had 6, right? Like the factors of 6 and 1, if can we find some way of adding to get 5 or minus 5? I think we can, right? Because then I can recognise 6 minus 1 would give 5. So there's some way I can tag a and minus, a negative on one of the numbers, or both, to get a negative, right? As long as they're different, I can somehow subtract them, these two numbers, to get minus 5. That's a successful pair. Okay, well then 6 and 1. Well then, but obviously then we've got negatives. So I'm going to need to somehow tag a negative on the 6 or the 1. Okay, well, what's the best way? Well, we need one number to be negative, because we have to multiply to give a negative 6. We can't have both negative though, because then remember a negative on the negative of the positive. So which one is a negative? Well, it has to add to give negative 5. So it makes sense for the bigger number to be negative. So minus 6 add 1 will give us minus 5, right? A negative result. And that's our pair. And so literally what we can say then is these are our factors, right? Because then we can say x minus 6, x plus 1. Okay, and there we are. That's simply all there is to it, that sort of method. Let's try again with part B. We have x squared plus 6x plus 8. Again, I'm going to want two numbers to times to give a and add to give positive 6. So again, I'm just reading off these two coefficients here. And again, the best way, let's consider the factors of 8 because we need to multiply to get to 8. So if 8 and 1, well, the difference is 7, so we're not going to get 6 from that. If we add them somehow or subtract, if we add or subtract, we're not going to get 6, right? We're either going to get 9 or 7. Then what about the next pair of factors? Well, what else goes into 8? 4 and 2, right? Well, these do. We can somehow get a 6 here if we add them. And actually, that's what we want to take because we want positive 8 and positive 6. So we want 4 and 2 as they are, right? Positive 4 and positive 2. And those are our factors. So then we have x plus 4, x plus 2. And that's our result, okay? So these are our two factors for that quadratic expression. Okay, cool. Part C, 6x squared minus 11x minus 10. Now, this is a bit more complicated because we have a coefficient, a number in front of the x squared. Okay. Um, so part A and part B specifically are called monic quadratics. Mono meaning one. Okay, meaning that the coefficient of the x squared is 1. So we can use this method as we just saw. But when you have non-monic quadratics, which is when obviously you have a coefficient, in front of the x. So here's 6 is the coefficient. A coefficient that isn't 1, okay? Um, what you need to do instead is we can't simply just jump into times minus 10 and add to give minus 11. What you instead need to do is adjust this a little bit by instead of minus 10, we're going to consider the factors of minus 60, which comes from 6 times minus 10. So you always times the coefficient by the by the number in front, so the minus 10. So we instead of considering the factors of minus 10, we're considering the factors of minus 60, which is 6 times 10. Okay, and then we add exactly to give minus 11. Okay, that bit hasn't changed. So it's a slightly adjusted method, but the method's generally the same. Okay, so minus 60 and minus 11. Well, let's just consider the factors of 60. So 60 and 1. Then 30, well, that's not going to get us anywhere near 11. 30 and 2, again, 28 or 32, not really in the ballpark. What about 3? Yes, 20 and 3. Their difference is 17. So no, not really. Does 4 go into it? Well, 40 does. 40 times 4, 40 is a factor of 4. 40, 44, 48, 52, 56, 60, yes. So 4, and then 40 is 10, so 44 is 11, 48 is 12, 52 is 13, 56, 14, 60 would be 15. Okay, obviously you could just compute that division yourself. 15 times 4 is 60. Um, and actually this will give us 11 somehow if we subtract the 15 by the 14 in some way. Okay. But we want negative 60 and negative 11, so not 60 and 11. But obviously this tells us the pair that we want to pick. Okay, so somehow this gives us 11, this pair of numbers, this factor. But we want negative 60, so we want one of them to be a negative. Okay, so 15 or 4, but then also we want them to add to minus 11. So again, we're going to pick the highest number to be negative, because then add a number, get a negative. So negative 15 and 4. So then 4 times minus 15 is minus 60, and minus 15 add 4 is minus 11. So we're good. So minus 15 and 4, what we want. Now, we cannot straight away then jump into, say, x minus 15, x plus 4. That's not what we do. And you can spot that's wrong as well, because if you expanded it, you're going to get x squared, not 6x squared, which is what we want. But what this does tell us is actually the best way to split up the minus 11x. What we're going to do now, this is quite a crafty thing, is what we can say is 6x squared, and then we can split minus 11x up to minus 15x and 4x instead. So 6x squared minus 15x, add 4x minus 10. That will still add to minus 11, which is why we needed to add to minus 11. So this is still identical to the original quadratic we had. We just found a way, and that's what this whole method does here, is finding a way of splitting up this 11 this x term into two different terms. And why is that important? Well, now we can factorize both parts separately. And what you'll spot is with this method, you will always get a common factor. So let's have a look then. So let's start with the first part. From what I've experienced, it doesn't matter which way you put these two numbers. The common factor should be the same no matter what. But anyway, so 6x squared minus 15x. Well, first of all, I know 3 goes into both of them. So 3 and then x as well. So 3x, and then to get to 6x squared, we need 2x, right? And then minus to get to minus 15x, we need, well, minus 5. Because then 3x times minus 5 is minus 15x. Okay, add. And then what about the second part? Well, the only common factor there is 2, isn't it? 2 goes into both of them. That's really it. So then 2 lots of 2x, we get 4x. And then minus 5, we get minus 10. Now, what do you notice? We got a common factor in both parts. So because this bracket is the same in both in all the terms, right? We can factor that out, just like we did before. So then we could say 2x minus 5, we could bring that to the front. And then for the first part, that's multiplied by 3x. And then for the second part, we add 2, because that's then multiplied by 2. And that is our factorization, okay? And you notice this will work now because 2x times 3x will give us 6x squared. And you can check if you expand it, you will get exactly the original quadratic we got, okay? So that's just you should have seen that GCSE, but that's a refresher's course. We will look at another example when we look at the exercises. Okay, but part D then is x squared minus 25. Now with this one, you could potentially do what we did before, but then recognize we have 0x minus 25. So we want factors of 25, but then that add to 0. However, what you need to spot these sort of terms, when we have two square numbers and recognize 25 is 5 squared, so 25 is a square number. When we have an expression of the form x squared minus a squared, so you have two square numbers subtracted from one another, but you can immediately factor as x minus a, x plus a, okay? So that's called difference of two squares, and that can come in handy when you know to spot it. Okay, so when you can spot, we've got a difference of two squares, which is in the name, but we're taking the difference and they're both two square numbers. We can use this factorization here. So in this case, well, we want x squared minus 25. We'll then say x minus, well, the root of this, so it'd be 5. So root 25 would be 5, then x plus 5, okay? And that will always work when you can spot this. And if you expand it, you will get exactly that result back. And the whole idea with that is to avoid having an x term, right? Because then you only have an x squared and a number. Okay, part A. Um, we have 4x squared. Oh, minus 9y squared. And again, we need to spot these square numbers. So here, 4x squared, if you almost root both terms, right? If you root 4x squared, you'll get 2x, right? So 2x all squared will get us to 4x squared. Then what about the 9y squared? Well, that'd be 3y, wouldn't it? So we have minus 3y, because then 3y all squared will get us 9y squared. Because then 3y times 3y would be 9y squared. Okay, and then so 2x minus 3y, 2x plus 3y. Okay, and that's it. So when you recognise difference of two squares, you can immediately jump to the factorisation without to do the method we did before in the other parts of the question. Especially when we get to rationalising the denominator later on in the chapter, the difference of two squares will really be helpful. Yeah, okay. Question 8. We can then factorize other expressions. So here for part A, we have x cubed minus 2x squared. Well, what term again is common on both? Well, x squared, really. And if we have another x, we get x cubed. And then for the second part, well, it's just minus 2. Because then that'll get us minus 2x squared. We can't factorize that anymore. Again, as there's no more common factors really that we can pull out. Okay, let's have a look at part B. X cubed minus 25x. Again, I recognise that we can pull out an x to both parts, both terms, and then we need an x squared to get to x cubed, and then minus 25. Okay, but hopefully, should be alarm bells ringing that actually we can factorise even more because we have a difference of two squares. So x remains outside. Then we can factorise inside the bracket, so x squared minus 25 into more factors. So again, difference of two squares. So x will square together with x squared, and then 5 will square to get 25. So we're going to have x minus 5, x plus 5. And that we can't simplify either or any of those anymore. So that's our fully factorized form. Okay, and hopefully when we say factorize completely, especially with algebra, hopefully start to realize a little bit now that the main idea is to reduce the powers as much. Well, we might create more factors, but we ideally want to reduce the power of each factor. So originally we had an x cubed term, and now we only got an x term in each factor. Okay. So it massively simplifies it, and when you factorize fully, we can it will help us with stuff like graph sketching, as it allows us to spot the roots and solutions of whatnot. But when we say factorize completely or as much as possible, this is what we mean, right? Pulling it to all the factors, as many as we can spot, and as simplified as possible, so we reduce the power. And that's the idea. Okay, part C, x cubed add 3x squared minus 10x. Well, before we do anything, I reckon I can pull an x out. And then we're going to have x squared, and then plus a 3x, and then a minus 10. Okay. Now, actually, we might be able to factorize a quadratic. Let's see what, if we used the method did before, let's see what we get. So to factorize this part, again, we need two numbers at times to give minus 10 and add to give positive 3. Okay. So to help with that again, the factors of 10, if I do it up here, by 10 and 1, but if I add or subtract them, I either get 9 or 11. That's not going to get us 3. Then the next factor 5 and 2, and this will be it because if I can subtract them, I get a 3. Okay, but then I want the times to give minus 10, so I need one of them to be a negative, but I need a positive 3 if I add them. So this time I'm going to need the lower number to be negative. So if I still times them, I get a negative because positive times negative is a negative. But if I add them, I still get positive because then 5 minus 2 is positive 3. Those are our factors, right? So you have x, and then it'll be x plus 5, x minus 2. Okay, cool. And again, if you were a bit unsure, you can check your answer again by expanding the brackets to see that you get the original expression back. Okay. There we are. So that's really the whole exercise. Well, that should be a good refreshing GCSE recap. But we are going to look at more complicated questions. Okay, questions where you will be putting your expanding and factorizing skills in the exam. The sort of question you might be asked to deal with involving these algebraic skills. Let's have a look at this first. Factorize completely. 6x cubed plus 7x squared minus 5x. Again, factorize. What can we can already factor in Excel. So x and then 6x squared plus 7x minus 5. Okay, then it says completely. So I need to factorize this even more. And I notice it's a quadratic. So I'm going to need to factorize it using the other method, where we consider two numbers at times and add to give something. But here, it's a non-monic quadratic, so we have a number in front of the x squared. So we need to adjust it, remember? So instead of times to give minus 5, you need to get minus 30, because then 6 times minus 5 gives us minus 30. And then add again to give plus 7. So then, to help with that, what's the factors of 30? Well, 30 and 1, that won't give us 7, if we combine them in some way. 15 and 2, again, no. What about 3? 10 and 3? Yes, because I notice if I subtract them, I can get 7. So that would be the pair to use. But again, now I need to work out what sign of the numbers, because we have a minus 30. I need one of the numbers to be a negative, but I need to add to get positive 7. So I need to pick the lower number again to be negative, don't I? To ensure 10 minus 3 is positive 7, so I get a positive when you add, but I get a negative when you multiply. So those are not the factors, but remember this tells us a way of if I rewrite the quadratic part, this tells us the way to split up the 7x, okay? So then we have 6x squared plus 10x minus 3x, and again that will give us 7x, so we've done nothing bad mathematically there, that's all still true. Minus 5. And now I can factorise both components, right, separately. So if I factorise, well, the first two terms, 6x squared plus 10x, I notice x goes into both of them. So 2x and then 3x to get 6x squared, and then 5 to get 10x. And then for the second part, well, minus 3x and minus 5, there's no common, there's nothing we can pull out apart from -1, but we'll still take it, right? So -1, or we could just say negative, and then 3x plus 5, okay? So then -1 times -3 is -3x, and -1 times 5 is -5. And then notice we have a common factor on both of them, so we can pull that out. So 3x plus 5, and then we have 2x for the first part, and then minus the 1. So that is the factorised form of the quadratic. Therefore, then, if we were to factorise the whole expression, remember, 6x cubed plus 7x squared minus 5x. Remember, there was an x here. And then, remember, then I'll factorise the quadratic into these two linear factors. So then that'd be 3x plus 5, 2x minus 1. Cool. There we are. Let's have a look at note this question then. So we are given this expression here. So we are given that x cubed minus x squared minus 17x minus 15 is x plus 3, x squared plus bx plus c. So it's a little bit of a step up, but we can just apply exact same knowledge that we already know to help with it. We need to find the values of b and c. Well, again, we have brackets here, so it's probably actually best to expand it. Because then what I notice is I'll probably get this cubic, this polynomial term if I expand it. And that will allow me to see what the values of b and c are by looking at the coefficients. Okay, so we can expand this then. So that's going back to our last chapter. So again, for the first bracket, let's pick the first term x, and then we have to times by every term in the other bracket. So firstly, if we expand this out, x times x squared would be x cubed, x times bx would be bx squared, and then x times c would be cx. And then for the 3, the next term after the x, again we do the exact same thing, times by every term in the other bracket. So 3 times x squared would be plus 3x squared, and then 3 times bx would be 3bx, and then 3 times c would be plus 3c. Can we simplify it a little bit? Well, x cubed, we can't simplify, that's the only x cubed term. We have a bx squared and a 3x squared term. So what I can do is factor out, say, b plus 3 of x squared. Right, hopefully you can see what I've done there. We have bx squared plus 3. X squared is common. So then b plus 3 is what we can do there. And then what about the x terms? Well, we have cx and 3bx. So again, I could say c plus 3b all times by x. Hopefully, and then if you were to expand it, you'd get back cx and 3bx. Hopefully you can recognise we can factor that in that way. And then we have this last term, 3c. 3c is just a number, right? Remember, C's and B and A are just missing numbers, okay? They're not, yeah. Okay, but then, if we were to then rewrite this other um, term here, what we were given, x cubed minus x squared minus 17x minus 15, well, what you can recognise now, we should be able to compare it. both sides. Well, x cubed, we get x cubed. That's great. Cool. But then it said minus x squared is equal. But we know we have b plus 3x squared. That means that minus x squared has to be b plus 3x squared, right? And therefore, if we cancel out the x squared, we have b plus 3 is negative 1. And there we can solve this equation, can't we? Because then b, if we subtract 3 to both sides, b would be negative 4. Okay. Um, so I found b. Okay. Then what about the next term, minus 17x? Okay. I could then compare minus 17 to c plus 3b, but a good strategy is look at the last number because there's only it's a lot less complicated than this. Because then the last number is minus 15, but then minus 15 has to equal the last number of the 3c, right? And that is a lot easier to solve because then if we just divide by 3, c would be minus 5. Okay, so we found those missing values. This method is, if you did it for the first time, it takes some time to think about what's done there, but particularly when you move on later on in the courses, you will see this method a lot. This is called comparing coefficients, which again is kind of in the name. So I've compared basically the coefficients of all the individual terms on the left and the right hand side, and they have to be equal. So then this minus 1, for example, the x squared, that minus 1 term has to equal the b plus 3 term outside this x squared. Okay, so that allows me to deduce b plus 3 is minus 1, for example, and that allows me to work out the missing value. Okay, so now we can actually just, if I actually get rid of all this now, now I've found the missing values, I can substitute that into what we've got up here. So this would be then x plus 3, x squared, and bx. So bx is minus 4, so it'll be minus 4x, and c is minus 5. Okay. I'm going to write that down here. This C bit, so I can get rid of this to make more space. Okay, cool. So that's part A, and then part B. It's asking us to fully factorize. So it's asking us to factorize even further. Well, the only thing we can factorize is this quadratic part. And again, well, it's a quadratic, and it's an easy quadratic. It's again only just x squared, no number in front. So we can simply just consider what times to give minus 5 and adds to give minus 4. Okay, again, that's these two numbers in front. There. And again, let's consider the factors then of 5. So 5 and 1. Well, this actually does, because then 5 minus 1 gives us 4. So we can find some way if we put the negative in the right place to get these two results, minus 5 and minus 4. Okay, well, I need two numbers times to give minus 5, so one of them has to be negative. But then I need an add to give negative as well, so it makes sense for the bigger number to be negative. So if I add, I get a negative. So then minus 5 add 1 is minus 4, and obviously they times to give minus 5. So a factor then of x squared minus 4x minus 5, we can say it's x minus 5 and x plus 1. Okay, and that is fully factorized now. We can't do it any more with that. There's no more numbers we can pull out. We can't factorize algebraically, like it's linear, so it's as far as it goes. Okay, we can't like reduce the powers down anymore. And there we are. That's fully factorized. So that's the main bit. So now we'll look at some challenge questions to really end it off to really stretch and challenge. So part A actually will need to be able to do at some point. They do like throwing these sort of questions in. But 4x to the 4 minus 13x squared plus 9. Again, we need to factorize fully. But the problem, we can't factorize anything out at the moment. But what you should notice is actually this resembles a quadratic, doesn't it? Because then if we say that u was x squared, we can transform this into 4 over u squared. Remember, x squared, to get to x to the 4, we can say that's x squared, all squared, right? And then remember the power law, remember what we did with the index law at the start of this chapter. If you have a bracket like this, that's all raised to a power, we times the powers together. So 2 times 2 is x to the 4. So if I square x squared, or I square u, so u squared would be x to the 4, then I get 4u squared minus 13u, x squared is u, plus 9. Now this is exactly a quadratic. Okay, this is called a disguised quadratic, and we will look at more of this in the next chapter when you look at quadratics. Because it can be transformed or made into a quadratic. It looks like a quadratic, but it's not exactly a quadratic. It's a disguised quadratic. Okay. So now we have it in quadratic form, and the best idea with these sort of disguised quadratics is to use a substitution, so sum it with replace to make it clear we have a quadratic. Okay, but now we can factorize this, treat it as because we have a u squared minus u squared u and a constant, so it's a quadratic term, right? Again, so we can know how to factorize quadratics like we saw earlier, but again, it's a harder quadratic because we have a 4 in the front of the u squared. So instead of considering plus 9, we need to consider 9 times 4, which is 36. Okay. Then we need to add to get minus 13. So how are we going to help with that? Well, we consider the factors of 36. Okay. So 36 and 1, no, we're not going to get 13 here. 18 and 2, no, if we take the difference, it can be 16, that's not minus 13. What about 3? 3 and 12? If we add to get 15 and subtract to get 9, that's not going to help. Another factor maybe? 4? Yeah, 9 and 4. Yes, that will help because we can add them in some way to get 13. So there we are. But we need one negative, right? Because we need to add to get a negative, but we need to time to get a positive. Okay, so we need to get well, if we need negative 13, we need one of them, at least one of them, to be negative, but we need to time to get a positive number. Well, if we times two negatives, you get a positive. So the only way we're going to do that is to make both of these negative. So that means this factor. So then, remember, we can split this minus 13u using these two numbers to say it's 4u squared minus 9u minus 4u add 9. Okay. And again, then I'm going to factorize both parts separately. So 4u squared minus 9. Well, the only thing that goes into it is a u, really. So u and then 4u minus 9. And then we're going to have you could just leave it as minus 4u plus 9. But then I want a common factor. Well, the only way I can do that is to pull out a negative, right? So I pull out a negative, then it'd be negative 4u minus 9. Because then minus 9 times minus 1, we get plus 9. And now we have the same quadratic, okay? Because then we're going to be left with u minus 1, 4u minus 9. And that's fully factorized. That's great. However, the last step is actually, this is u, not x. So to get back to x, because we want to factorize for x, not u, we just bring it back in. So then we say x squared minus 1 for u, and then 4x squared minus 9. Okay, but actually, we can do more with this, can't we? Because I can factorize this even more, because we could factorize now, because remember we have an x squared term. These are not linear. These brackets. We have an x squared term. Linear, by the way, means it's simply ax plus b. So, for example, 2x plus 5. It's like a straight line. Okay, but because we have a quadratic, we have a degree a power of 2. We could simplify it further into a linear, right? A term with only an x with degree of 1, if you will. And actually, we can how to factorise it, and we can because these are difference of two squares, aren't they? Both of them actually. So firstly, the x squared minus 1, we've got a difference. Well, x squared and 1 is a square because then x squared, well, x goes into x squared, and then 1 obviously goes into 1. So we can say x minus 1, x plus 1 is the factorisation of x squared minus 1. Okay? And then likewise for the other bracket, 4x squared minus 9, well, 2x and 3 are the square, are like the roots, right? The things that square to get 4x minus 9. So we're going to again have 2x minus 3, 2x plus 3. Okay? And that is now factorized as fully as possible. They're all linear. We can't do any more of that. We can't pull out any numbers or constant coefficients in front. So that's fully factorized then. There we are. See what's a challenge question. There's a lot of moving parts to that question. Brought effort together. But good question that is. But hopefully you recognise that we've done nothing that more really than using index laws, and we use the exact same approach of factorisation, right? Difference of two squares and factorising a quadratic. Nothing new there, but it's brought everything together. Hopefully you can see what we've done there. Okay, part B. Part B is a proper hard question. We have 2x squared plus 5xy minus 3y squared. The key difference this time is we got another number, we've got another algebraic term involved. We've got a y, okay? Um, and they don't ask this, don't worry, this particular sort of question should be examined or whatever, but it's a good challenge question, especially if you're looking at STEP or math, for if you're applying for maths at uni later on or whatever. This is not a bad question to look at. But we can still apply exactly what we know. We can apply the exact same procedure. Just don't be thrown off by the y. Because like, well, if we say we keep a polynomial, say this is quadratic for x, right? Uh, Again, the a term is going to be 2. But then if we just treat y as a number, y is another number constant, right? Well, we could say the b term, remember we have ax squared plus bx plus c as a quadratic. The b would be 5y, and then c would be minus 3y squared, okay? So all I've done there is basically treat y as another number. It's x that I'm interested in, but y is just a number, right? It's kind of like, almost like, saw earlier. What question was it? Here, right? When the b's and the c, the b and c's are just numbers. There might be algebra. B and c are letters, but they could just be fixed. The numbers, right? They're constants. Um, but X is actually what we're interested in. So that we could treat it in the same way here. So Y is just a number. Okay, so we could just treat Y, and yeah, and then we can apply the exact same procedure. Well, what would be the procedure? Well, again, A is X squared. It has a number of 2 in front. So we need to adjust. So we need, instead of looking at numbers at times to give minus 3y squared to see the number at the end, we need to times by 2. Okay. So then the 2 times minus 3y squared will be minus 6y squared. And we need to add to give 5y. Okay, so we need 2 times that give add to give 5y and times to give minus 6y squared. Okay, how is that going to look then? Well, let's think about it. We need 2 numbers that add to give 5y and time to give minus 6y squared. Well, actually, I think the best way is to consider, well, what if we had numbers a, y, and by instead of just a and b? So 2 numbers then. Uh, um, so say 2 numbers that add to give 5y. So in other words, the coefficients a and b would give us 5, right? So if we add ay to by, we get 5y. And then if we times ay by by, we're going to get minus 6y squared. And we recognise that because y times y would be y squared. So actually, what this boils down to is looking for two numbers that gives 5 and two numbers at times to give -6. Right, hopefully you can see that, and that is the exact same approach. But how are we going to work that out? Well, then, what are the factors of 6? 6 and 1. Well, 6 minus 1 gives us 5. So really, we want two numbers to give add 5 and times to give 6. Because then we can tag them with a y. Um, to make sure we account for the fact we have 5y, not just 5, and 6y squared and then just -6, you know. But we found it because then 6 minus 1, that will give us add to 5 somehow if you subtract them. Okay, so mind that clear here. So we want to add to give 5 and time to give -6. Well, 6 and 1 then. Well, I need time to give -6. So one of the numbers has to be negative. But if I want to add to give 5, well, I need them big numbers to be positive, right? So then -1 has to be a negative to give a positive number. So then 6 minus 1 will give us +5. 6 times -1 will be -6. And that's our number, right? So then that's telling us that AY would be, well, A could be 6Y, doesn't matter. And then BY would be -Y, okay? So that's just the coefficients for the Y. Uh, and now we can split this up. So we can split the coefficient, the 5Y up into 6Y minus Y. And then we can say that this goes to 2x squared plus 6yx, right? Minus yx minus 3y squared. And if you remember, check, if you add 6yx minus yx, you get 5yx, which is 5xy, which is what we got at the start, okay? So that we do it again, that's all fine, that's great. And now, again, exact same approach now. We can complete and factorize both parts separately. So again, I recognize 2 and an x is common to both. So we're going to have 2x times x, and then I'm going to have 3y, because then 3y times 2x is 6xy, or yx. And then for the second part, well, I can factor a negative out, but also y is common. So I can factor out minus y, and then I'm going to have pot x to get minus yx. And then plus 3y. So then 3y times minus y would be minus 3y squared. And now I can bring this all together to then left with x plus 3y. No, it's common. So I can say x plus 3y. I can bring that out as a common factor. And then we're left with 2x minus y. And let me write that a bit clearer. And that is fully sim factorized. We can't do anything more of that. But yeah, so again, notice that we just applied the same procedure, but now we obviously have a y involved. So all we have to do is basically tag on a y. But yeah, it's a really nice challenge question, a really stretchy challenge, um, and to really test your knowledge. Okay, cool. So I'm going to leave that there then.